Hi. In this video, we're going to talk about properties of triangles. And these are not the typical properties of a triangle having three sides and those things. It's more complex. And so the first one we're going to look at is the triangle sum theorem, which states the sum of the measures of the triangle, or the sum of the measures of the angles of a triangle equal 180 degrees. So all of the measures of the three angles in a triangle should add up to be 180 degrees. We're also going to look at the isosceles triangle theorem. Now, the isosceles triangle theorem, or ITT for short, says if two sides of a triangle are congruent, then their opposite angles are congruent. Conversely, so the converse of that would be if two angles are congruent in a triangle, then their opposite sides are congruent, both of which are true. And that's not always the case of theorems. The theorem and then the converse are always true. That's not always the case. However, in this situation, it is. And so let's look at some problems within that. I have triangle ABC, and I have two sides that are congruent. Well, by the isosceles triangle theorem, I know that angle C is 63 degrees. And then by the triangle sum theorem, which tells me that the sum of all of these angle measures are 180, I know that x would be 54 degrees. And so then I could state that x is 54 degrees by the isosceles triangle theorem and the triangle sum theorem. Our next example shows us a triangle with two congruent angles. So the converse of isosceles triangle theorem tells us that the opposite sides of those angles are congruent. It's important to note that it is not what you think of as the angles of the base. I want you to think of it in terms of the angles or the sides opposite of each other. And so in this case, it's the opposite, because you'll see some pictures and some triangles in very different positions and different shapes. We just want to make sure that we understand that relationship, that it's the opposite. So by the converse of isosceles triangle theorem, I can set the two congruent sides equal to each other and then solve for y. And I can say y is equal to 5 by the isosceles triangle theorem converse. The last kind of property or relationship we're going to look at are the midsegments of a triangle. Now, the midsegment is a segment that is formed whose endpoints are the midpoint of a side. So we can see here that this midpoint, or this midsegment Z, has a midpoint making this side and this side of the triangle congruent to each other, and likewise on the other side. So a relationship within the midsegment is, or there's two properties here. The midsegment is always going to be parallel to the third side of the triangle, but more importantly for what we're going to use it for is the length of a midsegment is half the length of the third side. So in this case, I can use that relationship to say that Z is equivalent to 10. And then I can use the fact that if this is a midsegment, which is based on these congruent markings, I know that X is equal to 8 because of these congruent segments. And then I know that y squared is equal to 12, which I can then solve to be y, the square root of 12, which then simplifies further to root 3, because 12 can break into the factors of 4 and 3, and the square root of 4 would be 2. So using all of these different properties, we can solve different algebraic problems within triangles and make sure that we understand the relationship between isosceles triangles and also midsegments of a triangle. Thanks for watching.